Good day guys! I'm Dan Sandil and I'm an industrial designer. So, I've been 3D printing since 2015 and it helps me a lot in making things from concepts to 3D model and then the real thing. Also in prototyping and fabrication. So, come and join us and I will discuss my experience and knowledge about 3D printing and the future of creating things. So, let's get started! So, there are two common 3D printers now in the market that are affordable and easy to use. The other one on your left side is the fuse deposition modeling, or what they call fuse fabrication filament or fuse filament fabrication, and the DLP or the direct light processing and SLA using UV light to cure the plastic. So, 3D printing is a is a process in which material is joined or solidified under the computer control to create a three-dimensional object using a CAD file or computer-aided design from a 3D model or a computer. So it is being used both as a rapid prototyping technology and additive manufacturing. So let's discuss about the pros and cons of this technology. So, on FDM, this one is can be printed in affordable cost and can be used and can be ready to use after printing. While on the DLP and SLA, it can print faster and more detailed than the FFF 3D printer. So, what are their cons, or what are the disadvantage of using both technology? So this one, the printing is slower and the lines are visible. While on this side, the DLP, the cons is it must be cleaned first before cured or UV cured or cured in sunlight. Okay? So as you can see here, this one, that's the tilting mechanism of this 3D printer. Okay? So I'll discuss you about this printer later. So 3D printing made a big role in our battle against COVID-19. So 3D printing technology are utilized to make things for critical healthcare and frontliners due to shortage of PPE, ventilators, respirator parts, adapters, and other material supply. So as you can see in the picture, it was famous in making face shields and adapters. So these adapters are Venturi bulbs. And then this one is what I've designed for our medical frontliners and for them to use as a modified respirator like this one. So on the other side is the ear guards, the famous ear guards, which you can put on your back and then hold the mask or the N95 mask for you so that your ears will not sore. Then next is the respirator filter holder, which is designed or made because of the shortage in filter. They use 5 to 3 plies of tissue to make as a filter. Okay, so on this next slide, so these printed objects are done with the help of vinyled NCOV volunteers and SDC 3D and G3D. So on this side, this is the adapter or airflow adapter for this mask or modified respirator mask, or what we call more mask. So this one is is our delivery in Resin Cavite. So this picture is in G3D or global 3D systems, which is made in the Philippines. So here, on the other side of the picture is the laryngoscopy, which used medical grade resin. And this one is the respirator mask designed by G3D using their 3D printer, the T1000, and their resin. So this one is AO valve, which also help or focus on mask for the patients. They extend or they make valves or ventilators, and then put the adapters to the mask so that the patients can breathe, or the ventilator can help them breathe, and then they will split the ventilator for the patients for them to use. So these are my delivery to the doctors and other members of the medical community. And also I printed this face shield on last April to help our frontliners. So next is for most of you who don't know what is the difference of 2D and 3D, so this is it. So the other one is a flat, on the violet color is a flat shape or 2D shape, which has length and width, or are flat corners with sides, or the length and width, and then the shapes are sometimes triangle, rectangle, or any other shapes that are flat. While in the 3D shapes, there's another measurement, which is the height or XY axis. On the other side, or on the 2D shape, it only has X and Y axis. Okay, so on this picture, you will see the inkjet printer printing in a 2D object, which is a paper, and then the other side is the 3D printed Eiffel Tower using a 3D printer. So what is 3D modeling? So as you can see in this picture, 3D modeling is the process of using software to create a mathematical representation of a three-dimensional object or shape. The created object is called a 3D model, and these three-dimensional models are used in a variety of industries. So like film, television, video games, architecture, construction, product development, science, and medical industries. All use 3D models to visualize, simulate, and render graphics. So on the next slide, you can see that the process of 3D printing. First, you need to make a design so that you can 3D model it into your CAD software, which I will discuss later. So this is sample 3D model, and then put into a slicer software. The slicer software reads the 3D model and then convert it into a G-code or codes which the printer can read, and then translate into a 3D printed object. So like this one. So after printing it, you need to finish it, because there's lines that you will notice, and there's some hairy plastic on the each side. So you need to clean it. Okay? So the history of 3D printing. So most of you probably don't know the history of 3D printing. So I'll discuss it with you guys so that you will understand when the technology started or invented. So in 1981 to 1999, the toddlerhood of additive manufacturing. So in 1981, Hideo Kodama of Nagoya Municipal Industrial Research Institute published his account of a functional rapid prototyping system using photopolymers or like resin in this time. So 3 years later, in 1984, Charles Hall broke new ground by inventing stereolithography, which I showed you a while ago. So stereolithography lets designers create 3D models using digital data, which can then be used to create an object. So that's the first decade of 3D printing in 1980s to 1990s. So next is from 1999 to 2010, the 3D printing adolescence history. So in 1999 1999, scientists at Wake Forest Institute for Regenerative Medicine printed synthetic scaffolds of a human bladder and then coated them with the cells of human patient. Later I'll discuss about the 3D bioprinting. So in 2005 or 15 years ago, Dr. Adrian Bowyer, RepRap or from RepRap project, launched an open source initiative to create a 3D printer that could basically build itself or replicate. At least print most of its own parts. So they released the Darwin in 2008, which is a self-replicating printer that's able to do the replicating thing. Okay? So from 2011 to the present day, which is the 3D printing or the fourth industrial revolution. So the price of 3D printers fallen rapidly and become affordable, and the accuracy of 3D printer improved. So designers now are no longer limited to printing with plastic. Now you can print using gold, silver, or other metal or material. So engineers at University of Southampton have flown the world's first 3D printed unmanned aircraft, and Core Ecologic prototype will be a car with a 3D printed body that's built to get 200 miles per gallon on the freeway.